Hello dear students, my name is SURAJ PRASAD and I am here senior lecturer at Sri Chaitanya Gosala campus, chemistry. Today we will be discussing a very important experiment, photoelectric effect experiment and its calculations. It is very important. Why I am saying so? Because it is coming in two parts, like it is coming in chemistry section also and it is coming in your physics section also as modern physics topic. In chemistry it is a topic of atomic structure and in physics it is modern physics topic. So it is very important for you. So let's proceed and try to understand photoelectric effect. You can see the diagram, something is reflecting by the diagram, some rays are coming and then some current is getting generated. So this is a glimpse of it. We'll learn it in detail in these experiments. So first of all, let's understand the meaning of photoelectric effect, that how do I define the photoelectric effect. So photoelectric effect definition is, it is a phenomenon of emission of electrons by the metals. Please see here, by which kind of metals? Light sensitive metals. By light sensitive metals. Means there are some metals which are excited easily by the light and the electrons they get lost. So it is like the phenomena of emission of electrons by metals, light sensitive one, when they are exposed to light of suitable frequency is called photoelectric effect and the emitted electrons are called photoelectrons. So please remember there are two keywords here. First of all, light sensitive, the thing which I have marked here, because not every metal would be like that. We will see that there will be elements which you know group 1 and group 2 elements. They are the elements which easily lose the electron. They have very less ionization potential. So it is very easy to remove the electron from there. So they are also light sensitive one, like cesium is there, okay, potassium is there. Even group 2 elements also are like that. Then important word is written over here, suitable frequency. Can you see suitable frequency? So it should be suitable frequency. And what is that suitable frequency? What is that called? In the next slides we are going to learn about it. A special name is given to it. It is called as threshold frequency. Threshold frequency. It is represented by nu naught value. So as you can see here, if the diagram is I hope you are able to see the diagram. So you can see that here potassium is the metal which is taken, potassium, and it is written the data we have, 2 electron volt energy is needed to eject the electron. 2 electron volt of energy is required to eject the electron. And 3 types of radiations, 3 types of light energy is getting passed. One is looking like red in color, one is looking like a yellowish in color, greenish yellowish, one is blue in color. Now you can see minimum requirement was 2 electron volt. This radiation, the red color radiation, can you see the red color radiation? What is the value written over here? 1.77 electron volt. So this will not be giving me the photoelectric effect. This will not be giving me the photoelectric effect. Then second, you see here also it is 2.01 electron volt. It is just sufficient to remove the electron. It is just sufficient, okay. That is why the electrons are on the surface and there is no further movement of the electron, no energy is there with the electron. So there will be no motion of the electron, no kinetic energy, and current cannot be generated from there. Then third is 3.1 electron volt. This energy is greater than 2 electron volt energy. So this, you can see the blue color small dots. Can you see the blue color dots, small dots coming out of this metal surface? This is the metal surface and these electrons are getting out for the third blue radiation. So it is like I am also wearing today blue, okay. So I am having a particular higher than the threshold energy also, and I will help you out by taking all the things in the deep from the books or from this class. in your mind that, okay, what do you mean by photoelectric effect? Totally, with all the types of questions, with all the formulas, graphs, everything I have for you in these slides. So suitable frequency is required, and I will tell you that that is called threshold frequency, and threshold frequency means the minimum frequency. So by that minimum energy we will get. So these are having the energies of a particular wavelength, particular color, you can see, but only this will be able to eject the electrons. Only in this the blue color small dotted electrons are getting out in this video. So this is causing the photoelectric effect. Let's move to the next slide. So everybody knows the name, and Sir Albert Einstein, he was the one who explained the photoelectric effect. Students, it is very, very important. Before that, if I would say, there were two more scientists, Hertz and Leonard, who tried to explain but not be successful in explaining the photoelectric effect. But Albert Einstein, he used the idea of Planck's quantum theory, saying the light as a particle concept, and on that basis he was able to explain photoelectric effect. And for this, students, he has got Nobel Prize also in the year 1921. Although he explained in 1905, here is the data written over here. You can see in 1905, Sir Albert Einstein explained this phenomena by the help of particle nature of light. As I am telling you earlier, the explanations were going on, but wave theory was in the mind, and that is why they were not able to predict or tell the exact thing, which Albert Einstein has done. He utilized the idea of Planck's quantum theory, where quantum of light were called photons. So they were like the particles, okay, they were like the particles, and it is like light particles, they are called photons. And for this he got the Nobel Prize in the year 1921, as I have mentioned to you. So here also you can see that just after his image, one diagram of photoelectric effect is only shown, where this is the metal surface, these are the electrons embedded here on the surface or inside it, and light rays are coming and some electrons are getting out of the system. Okay, so you can easily understand the concept of photoelectric effect. So please remember, sometimes it is asked very much that on what basis, on what nature he tried to explain. So please remember, photoelectric effect is based on particle nature. It is based on particle nature, it is not explained on the wave nature. Next is the characteristics of a photoelectric effect, which you should remember actually. Many times theoretical question comes, many times you will be asked some numerical question also where this theory is involved there. So you should learn each and every key point of photoelectric effect. The first point is threshold frequency, which I was talking to you earlier also in the previous slide, that this is the minimum frequency which needs to be supplied. If this is not supplied, then obviously electron will not out of the system. So threshold frequency, threshold energy or work function, just like the frequency, if we calculate the energy for it, it is called threshold energy of a particular metal surface, or the work function of any material. It is also called work function. It is phi naught symbol, the symbol is phi naught. So is different for a different material. Obviously every material is different in its own property. So the value of the threshold energy, the minimum amount of energy which is required to eject out the electron, that will be obviously different. The minimum frequency which is required to eject out the electron, that will be different. So you can just imagine a system that there is a metallic surface and light is coming on this surface with some particular energy, particular wavelength, some particular frequency, and if it is equal to, or it is not, it should be actually greater than, equal to will also not cause the photoelectric current. So if that energy or the frequency which is required is more than that, the incident frequency, then obviously the electrons will get out from that system, from the surface, and it will be following the photoelectric effect. It will generate a photoelectric current. So this is the minimum requirements, okay, minimum frequency, so that is called threshold frequency, minimum energy, threshold energy, or the term work function is generally used for the materialistic property. then the kinetic energy of the photoelectrons is directly proportional to the frequency of the light used. This is very, very important because many times question is asked that kinetic energy depends upon what. So please remember, Ke depends on frequency of light used. Even the graph, when I will be teaching you, please remember this concept that the kinetic energy is dependent of the frequency of the light used, means incident light. Then the process is instantaneous, that is in fraction of seconds, so it does not take much time. Fraction of seconds, by I mean that within nanoseconds it generally occurs. So it is a very fast process, quick process. It is a metal, light of particular radiation came and electrons went out, very quick, very fast. Then there is something called stopping potential, V0, is directly proportional to the frequency of light used. So frequency of light used is again the way we calculated the kinetic energy, we will calculate the stopping potential also, and there also we will see that it will be dependent upon the frequency which is used as either F symbol or nu symbol. So it is used like both. So potential, stopping potential, I will also talk about the meaning of a stopping potential in the next slides. So it is actually the voltage which you will supply at the anode so that it will stop the photoelectric current. Okay, the current will be becoming zero. So that means photoelectric effect will be stopping. Current value I will be equal to 0. So to stop the photoelectric effect, what is the requirement of the potential? That is called stopping potential. We will derive the relation, okay, afterwards. Then photoelectric current is proportional to the intensity of the light used. Again, many times, as I have told you, question it comes about the intensity and about the frequency. So your this thing should be very much clear about the intensity and about the frequency. Kinetic energy depends upon the frequency, stopping potential depends upon the frequency, but the current value, it depends upon what? It depends upon the intensity, means brightness. So a dim light or a bright light, how many photons will be there? Obviously current is what? Current is the Q by T. Okay, so per second how much charge is getting passed. So if the number will be more, this will be more. So that is how it is proportional to the intensity of the light used. Then this is Einstein photoelectric equation. By the help of this equation, we will be deriving or we will be solving the questions of our chapter. Now, here again, same diagram, same stuff again and again. This is the sea of electron inside the metal waiting to be set free. Okay, by that it may become stable system. So light of particular radiation is coming, incoming radiation, and electrons are knocked out. So it is possible only if it is crossing a minimum frequency requirement, which I told you, threshold frequency. If threshold frequency is given to it, threshold energy corresponding to the threshold frequency is given to it, then definitely this will lead to the kinetic energy to this system of the electron, and that is how it is mentioned. H nu, by the Planck's quantum theory, you already know E is equal to h nu. So h nu is equal to h nu naught also it is written, or phi naught also it is written. This is the work function. This is the work function or the threshold energy. So some amount of this incident radiation is spent for the work function, and rest all the energy whatever was incident, it is supplied in the form of kinetic energy, and you know the kinetic energy formula, K is equal to half mv square. So by that we have this relation that suppose this is your h nu coming, okay, this is the incident radiation, h nu energy, and this is the metal. So suppose it is having the phi naught as the work function. So h nu will be equal to phi naught, which is the minimum requirement to remove the electron, and the rest all the energy is converted into the kinetic energy of this electron, which is called Ke max if we are calculating from the surface. If we are calculating from the surface, it is called Ke max. So you just have to imagine that these all electrons are right now at the surface, and this radiation is provided on the surface. That is how we will call it Ke max. otherwise it will be not a maximum kinetic energy, it will be just a kinetic energy. Okay. So Ke max I am writing, so that is why half mv square max will also come, okay, because maximum mass cannot be anything, mass will be the constant, so velocity can be maximum, so that is how Ke max will be written as half mv square max. Okay. Then it is like phi naught we can represent as h nu naught. So your nu naught threshold frequency, nu frequency of the radiation, and h is called the Planck's constant. This equation is called as Einstein photoelectric equation, very important, you have to solve by this formula many questions. Then the thing which I was telling you, stopping potential. So here I have defined the stopping potential also. It is the minimum negative voltage supplied to the anode to stop the photocurrent. That means your I will be equal to 0 after supplying this much voltage. Now please remember students that it is represented by V naught also, and in some books it is represented as Vs also. So no issues, both are same thing only. So you should remember that what is the concept here. The concept is it is the minimum negative potential or negative voltage which is supplied to the anode to stop the photocurrent, because when you will supply the voltage to the anode, the direction will be opposite to the direction of photocurrent. So obviously it will try to minimize it, and at one point that current will totally get cancelled. That voltage will be called as stopping potential, Vs or V naught. Then the maximum kinetic energy of electrons equals the stopping voltage when measured in electron volt. See, photocurrent, how it is getting generated? It is getting generated by the help of your kinetic energy of the electrons, right? So if you equate the energy, if you equate the kinetic energy max with respect to the potential which you are finding, the stopping potential energy, then it will be like that. If suppose it is equal to this, then V naught will be called as the stopping potential. So if suppose I am saying voltage is V volts, so the energy associated with that particular particle will be E into V in the electron volt units. So EV naught will be equal to Ke max, and from here you can calculate the V naught, the stopping potential VO, as Ke max by E. So what is this Ke max? So this is called the stopping potential equation, where V naught is stopping potential, K max is kinetic energy, and E is the electron charge. It is not electrons, it is electron charge. Charge on an electron, which you already know, it is 1.602 into 10 power minus 19 coulombs. So you can convert in according to the various units, whatever is required. So this is how we calculate the stopping potential. So please remember the concept. The concept is, first is what is a photoelectric effect, that a particular radiation should come, and then particular if it is crossing the your threshold energy, threshold frequency kind of thing, then definitely current will be generated. That is the photoelectric effect. To stop the photoelectric effect, the potential, the reverse potential, the negative potential, whatever you say, what is required is called the stopping potential. So formula is very, very important, students. Questions will majorly come from the formulas. Now this is another section from where the question comes, and that is graphs. Okay, so graphs in the photoelectric effect. You can see here I have drawn some graphs, even some more are there in the next slides as well. So electron kinetic energy versus frequency. So we have just seen, students, in the previous slides, that kinetic energy is dependent upon the frequency of the radiation, frequency of the incident light. So it is directly proportional to it. A straight line is getting passed, you can see that. But after crossing certain frequency, which is called as threshold frequency, it is written here nu naught. I hope you can see the curve. It is written nu naught. So this is your threshold frequency. Then kinetic energy versus intensity. Kinetic energy is not dependent upon intensity. Please again, kinetic energy is not dependent upon intensity. So it will be a straight line curve. Okay, it will be a straight line curve. Similarly, current versus frequency. Current versus frequency. current is dependent on intensity, not on frequency. So it is a straight line here, current versus frequency, and current versus your intensity will be a straight line passing through the origin. Okay, this is a straight line parallel to the frequency. This is also a straight line parallel to the intensity axis, but this is a straight line passing through the origin, like directly proportional, linear curve. Okay, this will be a linear curve kind of thing. So this is what very important for you to remember, that which quantity depends upon intensity, which quantity depends upon the frequency, because many times students they get confused. So please take a note of it very carefully. Then this graph sometimes is asked between, suppose two metals is given. So obviously I told you every metal will have different property, so different work function will be there. Now when you extrapolate this K versus the frequency curve, here you will get what? Here you will get your work function. Here you will get the work function. So this is the phi 1 work function for this metal. This is the phi 2 work function for metal 2. So like that. So here the negative axis which you are getting is the work function, which if I equate with respect to the K max, my photoelectric current will be 0, and that will be correspondingly called as your stopping potential. Okay, so like that you can relate. So please take a note of these kind of graph. When you extrapolate, this value comes out to be your work function. This is stopping potential versus frequency. Stopping potential versus frequency curve, students, just have a look at the graph. Stopping potential versus frequency. Stopping potential also is dependent upon frequency, I told you. So that is again dependent on frequency linearly, and when you extrapolate it, it will be equal to minus W by E. We have just seen that we have to divide by E, the charge value. So this was your, if it is the energy, then energy by the electron charge 1.6 into 10 power minus 19 coulomb will give you this value of stopping potential. Now this curve is again very important, although rarely asked for NEET exam, okay, but important. In physics it is somewhat more important than chemistry. So please take a note of it. I told you current is proportional to the intensity. Current is proportional to the intensity. So here you can see, if I am changing the intensity, my current is also changing. If you want to write me the trend will be obviously the one which is having higher intensity will be having higher current also. So here I can write the trend for you is that I3 is greater than I2 is greater than I1. Okay, this is the intensity, and based upon that you can get the value. So in short, we have covered photoelectric effect. Okay, we have covered the quantities, we have covered the formula to be used in the equation. Now we will do what? We will try to apply this formula and solve few questions, so that practice will be there. If you will not practice, then it is all waste. So you can see here in the diagram what is happening. In the diagram, light radiation is passed. First of all, light radiation is passed, and after that, from here, let's say this is the metallic surface, and from here the electrons are coming out to this plate, and then it is completing the circuit, and that is how my ammeter is giving me some value, okay, some milliamps value, and this bulb is also getting on. So this is what, this is your photoelectric current only. This is your photoelectric current. I hope you understand the diagram, students. Now, as I told you, question practice time it is. So you solve yourself, and then I will be also here solving with you. But you pause the video and also solve, and then tally your answers with me after again playing the video. Okay. So do question yourself, that is more important. See this question, according to Einstein photoelectric equation, the graph between the kinetic energy of photoelectrons ejected and the frequency of incident radiation. See, just now we have done the graphs part, Okay, many graphs I have told you with respect to intensity, with respect to frequency, with respect to other quantities, and based upon that, I hope you can directly tell me the answer. Very easy question asked already in the exam, and many times these are questions are getting asked. So you should be prepared enough to answer all these types of questions. Okay. So out of these, it is very simple. The correct answer is option number A. We have just seen that the Ke versus frequency, this curve is of this nature, and what is this point? This point is your nu naught value, and if you extrapolate this value, then this is going to give you the your work function. Okay. Next, a photosensitive metallic surface have work function h nu naught if the photons energy 2 h nu naught falls on this surface. The electrons come out with a maximum of velocity 4 into 10 power 6 meter per second. When the photon energy is increased to 5 h nu naught, then the maximum velocity of electrons will be what? See, first of all, I always say, whenever a question is given, if you understand the question pretty well, then 50% question is solved there it is. So we have to first understand the question. So there is a photosensitive metallic surface, okay? That means photoelectric effect can happen over here. And its work function, so I am writing here all the data. Work function phi naught is given as h nu naught. Now the question is saying that if the photons of energy 2 h nu naught falls on the surface, that means incident. It is talking about the incident energy. So if it is talking about the incident energy, so that is the first part. So the electrons come out with a maximum velocity of 4 into 10 power 6. That means I can do like that. Two cases I can take. In the first case, when I am supplying the energy as when I am supplying the energy as 2 h nu naught, for this I am getting a Vmax, maximum velocity of how much? 4 into 10 power 6 meter per second. Now, the second part of the question is that when the photon energy is increased to 5 h nu naught, so we are having another incident radiation with 5 h nu naught value, and it is asking now that what is Vmax value equal to. All these things will be solved by the help of those equations only which I have taught you. So nothing much to worry about it. We have to form the equations here. See, when we write energy, so that means h nu is equal to h nu naught plus K max or half mv max square. This is the Einstein photoelectric equation. Now from there, can I have this relation? H nu minus h nu naught is equal to half mv max whole square, right? So this is my incident energy, this is my threshold energy, and that is my velocity part. So based on this, we'll be making two equations over here. Like for this part, for the first part, we can write like this way. It is 2 h nu naught, right? So, and the threshold is how much? Threshold is h nu naught. So we can write like this way. For our first equation will be 2 h nu naught minus h nu naught is equal to half m Vmax square, half m Vmax square. Okay. So what was the Vmax? Vmax for the first part is given to you, just check it out. That is 4 into 10 power 6. 4 into 10 power 6. So I can write it as 4 into 10 power 6 whole square. Similarly, I am writing the second equation, 5 h nu naught minus, this is my equation number 1 and another will be equation number 2. So 5 h nu naught minus, see threshold will be same because I am talking of the same material, so threshold will not change. So 5 h nu naught minus h nu naught, it is equal to half m, this V max we have to find, so V max whole square, this is equation number 2. Now the question is very simple, very sulabham I think. From here you get the value, just divide them and you will get the V max value for the second part. So you can see that what we are getting, 2 h nu naught minus h nu naught, that is giving me h nu naught divided by 5 h nu naught minus h nu naught, that is 4 h nu naught, and it is equal to this and this will get cancelled, right? Half m will get cancelled if I divide, and you can simply write like here also 1 by 2, right? So this will be cancelling each other. So I will be left with the 4 into 10 power 6 divided by V max whole square. This also h nu naught will get cancelled. So it is 1 by 4, and if I take the square root of it, it will become 1 by 2. So this will become 1 by 2 is equal to 4 into 10 power 6 by V max. And from here you are directly getting V max is how much, students? V max is 8 into 10 power 6 meter per second. So if V max is 8 into 10 power 6 meter per second, let's see any option is there like that or not. Yes, there is an option number C. So very good to all the students who have done this question themselves, before I coming to the answer. Okay, correct answer is 8 into 10 power 6, and simply we have to use the Einstein equation. You can see, first of all we have to understand the question and then we have to apply in the equation the data from the given question. So these type of questions are also getting asked, and you have to form equations and solve for the 2 elements. Sometimes they can introduce 3 elements also, 3 materials also. So just take the information from your question and solve simply. The next question, light of 2 different frequencies whose photons have energy 1 electron volt and 2.5 electron volt respectively illuminate metallic surface whose work function is this much. So this time again we have been given phi naught value, that is 0.5 electron volt. This will be common to both the things, both the equation again. First energy they are giving as 1 electron volt, and second incident energy they are giving as 2.5 electron volt. Okay, illuminate the metallic surface. So the ratio of maximum speeds of emitted electrons will be what? Again it is talking about V max, similar to the question what we have solved in the previous question just before. So it is like a ratio of the maximum speed of emitted electrons. So again we will be doing the same procedure, like first we will form the equation with respect to the first condition. So it will be like 1 minus 0.5 divided by 2.5 minus 0.5 will be equal to half m will get cancelled. So I am directly writing the V max square ratios. Okay, so this is your V1 square, let's say V1 max, and this is your V2 square, and just now take out the ratio that how much it is coming. So from here if we will solve, it is like 0.5 divided by 2, right? 2.5 minus 0.5, this is equal to V1 by V2 whole square. So this will give us the ratio, because this will become 0.5 by 2 is how much, right? 0.2, this will become 0.5 by 2 will be 1 by 4. So 1 by 4 is equal to V1 by V2 whole square, and that will be making the ratio as 1 by 2. So V1 by V2, this ratio V1 by V2, these are V1 V2 I have assumed the maximum velocity. So that is coming the ratio 1:2. Yes, we have an option number B, 1:2 is the option. So students, we have solved the photoelectric effect questions by using Einstein photoelectric equation. We have understood the concept of the photoelectric effect as well, that what is photoelectric effect, what is the necessary condition, which quantities depend upon intensity, which quantities depend upon frequency, graphs we understood, okay, and photoelectric current also we understood with stopping potential values as well. So this is all about the photoelectric effect in our syllabus of chemistry. Rest you can do now all the questions of your module of NCERT based on photoelectric effect, which will be now easy for you because you have done the class with me. So for that, because you have done the class and completed all the tasks, so a very big thank you for all of you to attend this session. And I believe now you will do all the questions. Thank you for listening to me. Take care.